Okay, so welcome everyone back in the photogrammetry course. I will now give a very short introduction on what the main topic of the Photogrammetry II course in this term will be, and then we start with the main topic. So, most of the stuff has been said already in the beginning of the first photogrammetry course last term. So there's a second part which is shorter in terms of the lecturing and exercise time. So there's only 2 hours of lectures and 1 hour of exercise per week in this term, and then there's the additional tutorial which is the preparation for the exam in the end. Why is this relevant? This is relevant because these numbers are used to calculate the time that you are expected to spend on this course. So I made the calculations also last year, or last term. In last term we had something between 11 and 12 hours per week that you were supposed or are supposed to spend on the Photogrammetry I course. This is different now since the Photogrammetry II course is shorter. You should end up with something like spending 7 hours per week on the Photogrammetry II course. So this is roughly the expectation. So this is substantially less than last term. The reason for that is there's only 1 hour of exercise, only 2 hours of lecture in this term, and this also reduces the overall effort or overall time that you're supposed to spend on this course. Why is this important? Whenever you spend substantially more than 7 hours on that course, let me know. So if you start spending 8, 9, 10 hours on that course, then something is wrong. I hope that's not the case. So we will not have these large homework exercises this time. So no Hausübungen. We skipped that completely in order trying to meet these approximately 7-hour requirement, assuming that you spend something like 60 hours for the exam preparation. That was kind of one of the assumptions in these calculations. So whenever you spend substantially more than 7 hours on that course, please let me know or let Matthias know who is doing the exercises for this course. In terms of the exercises, so this year Matthias Hans, or this term Matthias Hans will take over both exercises. Last term he did one of the exercises and Susanne was doing the other exercise. No, both of them will be done by Matthias. So lectures, you know, we are here 10 to 12. We start 15 minutes after 10. Yeah, my email address, you know where my office is. If there's something which requires clarification or something that you want to complain about in this course, simply come to me. If you don't want to come to me, visit Matthias. He's sitting next to my office. Send him an email, talk to him in the tutorials whenever there's something wrong. About the exercises, so there are 2 blocks of exercises, 1 hour each. Matthias sent an email around 2 days ago or something like this about the assignment where you could enter what's your available time slot. He will make then, based on what has been submitted there, will make the assignment, who will be in the Monday 12 to 1 or 1 to 2 course. Again, there will be the MATLAB tutorial for those of you who have issues with MATLAB or need further support. So this is going to be continued, but this is something which is completely optional. This is something you don't have to do, you don't have to take into account, or don't have to consider to do if you don't need it. So this is completely optional. In terms of the exam, there's also the slide I showed last term, the exam for the whole photogrammetry module, that means Photogrammetry I and Photogrammetry II, will take place by the end of this term. And in order to be admitted to the exam, you need to have 50% of the points of the homework assignments from Photogrammetry I as well as from Photogrammetry II. So they don't add up, 50% of Photo 1, 50% of Photogrammetry II. Again, nothing has changed since last year. You can submit your homework assignments in groups of 2 people. Yeah, again, limit the collaboration between groups. This was not an issue last semester, so I don't expect any further upcoming issues. Just want to have that mentioned. Please don't copy your homework assignments. That should be clear, but it happened last year quite frequently. But last term it was completely fine with you guys. So I don't have doubts that this will be an issue here. The first tutorial starts next week, 26, and the first homework assignment has been given out by Matthias already, as far as I know. So you find everything on the eCampus site, as well as the same holds for the slides that I'm presenting here. So what happens in terms of the content that we're doing, or the topics that we're going to address in Photogrammetry II? So Photogrammetry I mainly covered things that had to do with images, single images. So images taken from a single camera. We have typically not taken into account multiple images taken from the same object from different locations, for example. There was one small exception when we looked into the stereo normal case, where we basically had two camera images, either two images taken from two cameras or two images taken from a camera while the camera was moved in between. It's kind of absolutely the same as long as the scene is static. And what we're doing now in Photogrammetry II is we move towards stereo photogrammetry. That means we have two images or pairs of images, and then generalize this to n images. So we try to see what changes or what information can we extract out of the scene if we use more than a single image. And the main focus of this course here is geometry estimation. So we are not looking in semantic estimation like classification approaches that we addressed in Photogrammetry I. We are looking here into the geometric reconstruction of the scene based on images taking either from multiple cameras, for example, synchronously at the same point in time. This is important to do if you consider dynamic scenes, or you can actually have one camera and you move that camera through the scene and you take multiple images. And the question is, what can we do with this information? So in terms of topics, kind of very roughly speaking what we're going to do, today we start with the relative orientation of two cameras. So given we have two cameras and we observe a scene, what can we say about the orientation of those two cameras? Then we will actually next week start with an approach to compute a direct solution for the relative orientation of two cameras. That means, given we have some corresponding points in the scene, can I estimate where the second image was taken relative to the first image? Then we go towards an iterative approach for this relative orientation. Then we look into the situation, what happens if we know where the camera locations are, and how can I actually identify or estimate the 3D structure of the scene. And then we're trying to solve everything at the same point in time. So estimating what the 3D scene looks like, as well as estimating where the camera locations are, which is something which is typically referred to as bundle adjustment. This is the least squares approach to this problem of estimating where are the cameras, or where have the cameras been at different points in time, and what is the location of 3D points in the scene. Then we look into autophotos, which is just one special photos taken, for example, from aerial images, which are used in order to build maps. All the approaches here relied on the fact that we have those corresponding points. So given we have an image taken at location 1, let's say from here, and a second image taken from here, all those approaches assume that we have those corresponding points. So that I know one pixel in image 1 corresponds to a certain pixel in image number 2. And these are those correspondencies. And the question is, how do we find those correspondencies? There's something we are going to address, and also procedures such as RANSAC. You may have heard about that. How do we deal with outliers, or how can we try to identify outliers in those data associations or in those correspondencies? And then as the last block, I want to look into recursive state estimation rather than offline or batch state estimation. So up to here, whatever happens is basically we take all the data that we have, all the images, put them all into kind of one algorithm and let the algorithm compute the solution. We come up typically with the best possible solution, given the algorithm which was applied, of course. But we are required to have all the images available also all the data must be available when we start our computations. And the question is, can we actually do a better job or save computational resources if we want to have a solution at every point in time? So whenever a new image comes in, I want to have the best possible solution, for example, where my camera is at the moment. So this is important if I want to estimate, for example, the state of a dynamic system or of a moving platform which moves through the scene, and at every point in time, I want to know where is the vehicle, for example, an autonomous car, or a car which takes measurements of the scene, a survey vehicle, and we want on the fly decide which areas we may need to reobserve in order to get better measurements. And this is something which is called recursive state estimation. So the Kalman filter is one prominent filtering approach to do that. We'll look into variants of the Kalman filter and then see how we can use this for the simultaneous localization and mapping problem, which is very, very related to bundle adjustment, which says we want to estimate the location of our camera, of our sensor, as well as the 3D structure of the scene at the same point in time. And we want to do that in an incremental fashion. So these are, on a very rough scale, the topics that we are going to address. The second slide just is slightly more detailed, also with the chapter numbers from the Wolfgang Förstner script, which is again the reference that I will be using here, at least up to here, so for the first 80% of the course. For the last 3 blocks over here, I will actually rely on a textbook and use this, work very close to a textbook, but up to here, everything is in line with the script, and all those numbers here are the chapter numbers in the script you actually find on eCampus. So the main problem is, if I want to reconstruct the 3D geometry of a scene giving images, is that our cameras only measure directions. So this is also one of the slides that I have showed in the motivation of the Photogrammetry I course. So if we have a scene in the world, like those mountains over here, and we take an image of that scene, what we are basically doing, every pixel corresponds to a direction. And we just know that this point lies somewhere on this green line. So we don't measure the proximity to the object or the distance to the object. The only thing that we are measuring are actually angles. So we just measure directions. So from one single image, I can typically not reconstruct the 3D geometry of the scene. In order to do that, I need multiple images, like 2 images. And if I know the corresponding points at what I was referring before, so if I know that this pixel over here corresponds to this pixel over here, so this is the same object in the scene which is pictured, then I can actually estimate that this is the 3D location of the object in the world. So by taking multiple images and by knowing from which locations those images have been taken, I can reconstruct the full scene. And I can also do that, for example, if I have multiple images, what you can see over here, this was actually the flight with one of the UAVs that we have here in the department, flying at Frankenforst, which is also part of the university on the other side of the Rhine. And then we can actually estimate the location of those points as well as the location of those cameras and reconstruct the location of those points in the scene. One of the examples that you can see here, so the house itself is actually a 3D model which is given, and all those red points are those points that have been measured with those cameras. You can actually see that most of the points actually lie on the surface of that building. And this is a problem of estimating the 3D structure of that scene given by all those red points. These are my measured 3D points in the environment, as well as at the same point in time estimating from where those points have been taken. So where was the camera at the different points in time. Next things we are looking into are orthophotos. These are aerial photos which have a special correction has been applied to those pictures in the sense that I can actually measure distances in those images. This requires some additional knowledge, so I need to know something about the terrain structure, but if I know something about the terrain structure, I can actually build those orthophotos and then directly perform measurements in those corrected images. And this is also something that we are going to address here in this course. So how to generate those images or those orthophotos given regular images and giving some information about the 3D geometry of the scene. So in terms of the literature, again, the photogrammetry script is the main reference on which I based the course. There's a second part, you can download it from eCampus. There's the Photogrammetric Computer Vision book, which is a book which is currently in press, which is basically a very large extension of this script, covering the topics in much more detail. And again, the notation is very similar to the script, so you should be also very well prepared if you look into this book. It goes more into the details, so you should be completely fine with the photogrammetry script unless you say, I want to go more into the details more than what I'm explaining here, then that is probably the right reference to look into. The Stachniss book was something I was using mainly in Photogrammetry I. You find the topics also in Photogrammetry II that we're addressing in this book, although I would stick to the script because from my point of view, or actually I'm working much closer to the script than with the book. Also, the Hartley Scissorman is kind of the Bible for multiple view geometry. That means when I have multiple images and I want to reconstruct the scene, it's also a very, very good textbook if you want to get more information about or more details about what I'm telling, this is probably the first reference to look into beside this book over here. The last 3 chapters come from the Probabilistic Robotics book, which addresses this incremental state estimation, so the recursive filtering. And here I'm working very closely in terms of notation, in terms of how the lecture is built on this book. The corresponding chapters are given. Several copies of this book are available in our library upstairs. That's it for the introduction. Are there any questions before we start with the technical topics? Anything you want to know? Okay, if this is not the case,